Hello, everyone. My name is Christiane Wilhelmsen. My pronouns are she, her, and I am the Executive Director at Georgia Strait Alliance. We're so happy you could join us tonight to talk about killer whales and contaminants. The first thing I would like to do, though, before we get started, is to acknowledge that the land we are meeting on, wherever you happen to be joining us this evening, is on the traditional and unceded territory of many nations. The offices of Georgia Strait Alliance are located on the unceded territories of the Squamish, Musqueam, and Tsleil-Waututh nations, also known as Vancouver, and of the Snuneymuxw Nation, also known as Nanaimo. Our staff and volunteers also work on unceded territories of many other Coast Salish nations. All these territories are also now home to many diverse First Nations, Inuit, and Métis people. Please take a moment to consider and acknowledge whose territory you are on, and make a commitment to learn more about the history of these nations before and since colonizations, and learn more about the community's active involvement in stewardship in your community today. We respect and honor the people of all territories and acknowledge that this land was never surrendered, relinquished, or handed over in any way. We also acknowledge the harms and mistakes of the past, and we are committed to moving forward in partnership with Indigenous nations and in the spirit of reconciliation and collaboration. May our actions correspond with our words in doing this every day. So just a bit of housekeeping before we get going. Just to acknowledge that you're going to see some great presentations today, and if you have any questions, we'll have some time at the end. So if you have any questions that we can ask our panelists, if you can put that in the Q&A section at the bottom. If you're having any technical difficulties or questions, you can put that in the chat, and someone will respond to you. I also want to note that this is being recorded, and we will share the recording with you in an email following up on this event. So I just want to, before I hand things over to our presenters, I do want to just give you a little bit of history of Georgia Strait Alliance and our work in trying to reduce pollution in the Salish Sea. So GSA is, for those of you who are not familiar with us, we're a marine conservation organization that for more than 30 years has been an active voice in trying to protect the waters of the Salish Sea. Our work has been always collaborative. We work with community leaders, small environmental groups, large environmental groups, industry, unions, governments of all sizes in order to identify threats to the region and find solutions to those threats. And sometimes finding solutions to those threats can take a very long time. If you're interested in learning more about our work outside of our efforts to protect southern resident killer whales, I encourage you to visit our website at georgiastrait.org. There's lots of information because we're active in a lot of different areas. But when it comes to a thread that you will see both historically but also today that runs through all our work, be it grassroots or big policy level work, it's reduction of contaminants and pollution in the region. In the 1990s, we were heavily involved in campaigns to reduce pollution from the pulp mills, as well as reduction of pollution from sewage from municipalities throughout the region. And as an example of how long this work can take, in the 90s, we were working on trying to get sewage treatment for Victoria. And last December, the capital region of District of Nanaimo of Victoria now has advanced sewage treatment, which is reducing the amount of pollutants that are entering this region. Today, we work on issues still related to sewage at times, but looking at other contaminants that are entering the region from other sources, as well as looking at oil spills and trying to reduce the impacts that inevitably small and large spills of fossil fuels have on this region. So our interest in contaminants and pollution is long because we know the impact it has on habitat and the creatures that live in the Salish Sea, and those impacts can last a long time. Over the last 3 years, we've been heavily involved in the work that's been done when it comes to southern resident killer whales, as the government set up technical working groups to look at various threats, including prey, the availability of Chinook salmon to the whales, as well as noise and disturbance. Georgia Strait Alliance has been active on the sanctuaries technical working group, but more importantly to this conversation, we've been involved in the contaminants working group. I have to say a very collaborative, science-based, but also looking at the future and trying to find solutions. It's been a real pleasure to be a part of that. We feel like there's good work been done, a lot more to do, but I think it's a good group of people, and we're going to see some, I hope, some big step forwards in the months to come. I think that's enough for me. If I'm happy to answer questions at the end, or if you want to reach out to me to ask more questions about our work around contaminants, always happy to engage. So now I will introduce our two speakers. I'm going to introduce them both, and then I will hand it off to our first speaker. So first up will be Shinjini Pilon, who is a program scientist with Whales Initiative Contaminants team at Environment and Climate Change Canada. The team is seeking to reduce the threat of contaminants to southern resident killer whales and other endangered whale species in Canada. Shinjini completed her master's and PhD degrees at the University of Ottawa, also my alma mater, in chemical and environmental toxicology. That's not my department. Her prior experience includes researching legacy pollutants in remote First Nations communities in Ontario and toxic algal blooms in several locations across Canada. She also has experience conducting human health and ecological risk assessments for contaminated sites. While she's not working, Shinjini enjoys being outdoors, canoe camping, cross-country skiing, and frequenting neighborhood parks with her daughter. And our second speaker is Kathleen McTavish. She's an environmental quality guideline specialist with the National Guidelines and Standards Office of Environment and Climate Change Canada. NGSO develops environmental quality guidelines, which you'll hear a lot about today, in various environmental media, including water, sediment, tissue, soil, groundwater, for a variety of chemical substances. Kathleen has been working with this group for the past 4 years, with a focus on developing water guidelines for various metals and organic substances. She's also involved with the Whales Initiative, helping recommend and develop EQGs, environmental quality guidelines, for the protection of southern resident orcas and their prey. In her free time, Kathleen enjoys camping, home brewing beer, and going for jogs with her dog. Have a lot of camping fans on this panel, which is wonderful. So I will pass the mic to Shinjini. Thank you both for being with us today.
Great, thank you. And thank you, Christiane, for the introduction and for hosting us. I'm really happy to be here today, really excited to talk a little bit about our research. And I should start my share screen process. That sometimes takes me a second to get going. Don't do this often enough to do it and talk at the same time. There we go. All right. So again, thank you again for having us. Really happy to be here. And so I'll be talking a little bit about the threat of contaminants, how it's impacting these whales, and a little bit about the actions that we're taking to try to mitigate the threat. And then Kathleen will go and take a closer look at specifically some of the work we're doing on environmental quality guidelines and how that relates to this population of whales. So to start with, I just wanted to give a little bit of background on these whales. I think for many of you who are here today to hear about this, you're probably already aware of the plight of the species. But to make sure we're all on the same page, the southern resident killer whales have been endangered for quite some time now, based on Canada's Species at Risk Act and also in the United States as well. Their current population size is 74. And in terms of their presence in the Salish Sea, there are really strong cultural ties and spiritual ties between Indigenous communities and coastal communities with these animals. So they're really revered by BC citizens and really citizens across the country. And their diet is comprised mostly of Chinook salmon. And the reason that I point that out specifically is because with low availability of Chinook salmon, it really relates strongly to their nutritional status and their ability to maintain their diet. So a little bit about the threats to these whales. Of course, the focus today is on contaminants, but I really want to make sure we kind of we're thinking about in terms of the other threats that these animals are facing, and these are threats that have human that are coming from human actions, we call them anthropogenic threats, And these include the availability of prey, as alluded to in the last slide. Chinook salmon, without access to Chinook salmon, they really they're unable to really maintain their nutritional status. From the perspective of vessels, acoustic disturbances as well as physical disturbances are really an issue for the whales as well. So thinking about vessel collisions and the extra noise from vessels kind of inhibiting their ability to hunt. They hunt using their echolocation capabilities, and having too much noise in their environment really affects that. And of course, the third threat that I wanted to mention is contaminants, and we'll be focusing on that today. And just wanted to mention also that so the contaminants threat we're targeting from the federal family through Environment and Climate Change Canada. We're leading that, and then the prey availability threat is being led mostly by Fisheries and Oceans Canada, and then again Transport Canada is leading the threat of vessels and noise disturbances. So again, focusing today on contaminants though. And how are these whales exposed to contaminants? Where are they coming from? So contaminants, so we call contaminants, we refer to chemicals as contaminants when they enter the environment and cause harm to different environmental compartments, to organisms, etc. So there are a whole bunch of different chemicals, thousands, that are released into the environment. And many end up in whale habitat, so in the ocean. They can come in through the air, through the water. Some of them get deposited into the sediments. And some of these contaminants are known as persistent. So we call them persistent pollutants. Sometimes we refer to them as forever chemicals, so meaning that they stick around for a really long time. They don't degrade very easily. They don't break down very easily in the environment. And some of these chemicals or contaminants have properties that make them accumulate within animals, within organisms in the aquatic environment. So that means that when an animal ingests the contaminant, rather than excreting it, rather than passing it out of the body, they remain. They accumulate within usually the fatty tissue and the fat of the animal. Many of these substances like fat, so that they really go and sequester into those fatty tissues. So as you probably know, killer whales have a lot of blubber, just as all whales do. And so there's a spot for those contaminants to end up in these animals. So I'll talk, I know Kathleen will be going into contaminant exposure a little bit more with her presentation, but I just wanted to mention as well that killer whales being at the top of the food chain, being top predators in their food chain, kind of magnifies this effect of accumulating substances, and we call this process biomagnification. And what it refers to is this increased concentrations of contaminants within the animal tissue for animals that are higher up in the food chain, so especially top predators. And I tried to depict that on the slide with the red circles there. So in response not only to the threat of contaminants, but the other threats I mentioned as well, availability of prey and disturbances from vessels, the federal government launched the Whales Initiative, which was launched in 2018. And this initiative supports the recovery not only of the southern resident killer whales, which is what we're talking about today, but two other endangered whale species that are found in Canadian waters. Later in 2018, an imminent threat assessment was conducted that was specific to the southern resident killer whale. And the result of the assessment was that it was found that these whales, the southern residents, are facing imminent threats to their survival and their recovery. And the reason I mentioned this assessment is part of what stemmed from this assessment was the formation of 5 technical working groups. And Christiane mentioned a couple of these earlier in the webinar. These technical working groups are collaborative in that there are a number of experts from different organizations and different agencies that have come together to provide advice based on the specific threats. So the technical working group that Environment and Climate Change Canada is chairing is of course the Contaminants Technical Working Group. And we are formed not only of all levels of government, including the province of BC, and we have representation from Metro Vancouver, but we have collaborations with university researchers and non-governmental organizations as well, including, of course, Georgia Strait Alliance. So it's a way for, it's a great spot for expert advice to come together to provide very scientific and very technical advice on the very specific topic of contaminants and southern resident killer whales. One of the first objectives of this technical working group was to figure out which contaminants we needed to focus on when it comes to southern resident killer whales. And so I mentioned before, there are thousands of chemicals that enter the environment. So to really figure out which contaminants we needed to focus on was really imperative to make sure we were focusing our efforts in the right spots. So we looked at a lot of different scientific studies and put together a lot of expert advice to figure out again which contaminants we needed to focus on. And so I won't go into the details of the different chemicals in this summary table, but I just wanted to point out that we had substances that we're looking at specifically for the whales, as well as a whole bunch of substances that were identified for their prey, for the Chinook salmon. For the substances that we have identified for the southern resident killer whales, these are substances that are known to bioaccumulate. So again, these are substances that are found typically within the fatty tissue, which stay within the animal, which contribute to their contaminant burden and are not easily excreted. Killer whales, I should have mentioned before, live for a long time, so they end up accumulating these contaminants, these substances through their lives, and again can have these really high concentrations of contaminants in their blood purr. So when we start talking about contaminants and chemicals and all these different substances, it kind of leads to the question, well, where are these coming from? What are the sources? And there are a whole bunch of different sources which bring different types of contaminants into the environment. So it's a complicated question with a complicated answer. And I've given a few examples of some of the sources that we are in the process of characterizing, but it is in no way inclusive of all of them. Christiane mentioned effluent from wastewater treatment plants. This is this is an ongoing source that we continue to work on and characterize. And we are also talking about effluent from industrial processes, including pulp and paper mills, mining effluent, runoff from agricultural practices, from roadways and surfaces, leachate coming from landfills. So again, this is not a conclusive list, but it's just to kind of give an idea of some of the sources that we are considering. So I wanted to talk also about some of the work that is in progress. Some of this is we're leading through our teams and our collaborations within Environment and Climate Change Canada. And some of this is in partnership with different members of the Contaminants Technical Working Group. So together we're in the final stages of putting together a contaminants mapping inventory tool. And the point of this tool is to develop something that will allow us to visualize where the contaminants are coming from and the different sources that these contaminants are coming from. So using available data, we have estimated releases of contaminants from different sources. So this includes, again, wastewater treatment plants, industrial sources, etc. All figuring out where the contaminants are ending up in whale habitat, and potentially leading to us being able to identify contaminant hotspots. So where are we seeing really high concentrations of contaminants? So again, this is in its final stages. We're really pushing to get this out soon, and we're hoping to be able to launch it to be publicly available soon. So so we can kind of keep moving on that. We're also working on recommending a number of guidelines, environmental quality guidelines that are protective not only of southern resident killer whales, but of other mammals as well. And Kathleen will talk a lot more about that during her presentation. One of the recommendations that came out of the Contaminants Technical Working Group was to share, to find better ways of sharing data among partners to really make sure that we are addressing knowledge gaps and addressing and making sure we're using all available data amongst all partners. And this maybe it seems pretty straightforward, but we have been finding, but we've been able to find ways to ensure that that we're working together, again, for example, with the province and with different regions, and collecting those data and sharing as needed. We are also, one of the other recommendations that came out of the group was to increase outreach to the public and to stakeholders to make them more aware of the threat of contaminants, what kind of contaminants we're talking about, and what actions can be done to mitigate this threat. So that's sort of like what we're doing here, kind of increasing education and trying to reach people and share the message on this threat. And lastly, under the Whales Initiative, we've been able to increase our monitoring capacities of the environment to better measure concentrations of contaminants that are found in the environment. So we are sampling air, freshwater, sediments, leachate from landfills, all to give us a better understanding of what kind of contaminant concentrations we are seeing in water, et cetera, that is leading into whale habitat or is in the habitat of their prey as well. This is one part of the puzzle. We are working collaboratively with scientists at the Department of Fisheries and Oceans, who are actually measuring contaminant concentrations in the tissue of Chinook salmon themselves, as well as the blubber of resident killer whales. And this, put together with our work in monitoring these contaminants in the environment, is giving us a better picture of where the contaminants are coming from and in what quantities, and which ones are actually ending up in the prey and in the whale. So lots of monitoring and research to add to the data that we have. I also wanted to mention a few other ongoing efforts under the federal government that are not related, that are not under the Whales Initiative, but really relate to our work and are really key in moving forward with enhancing protection for southern resident killer whales. So for example, we are enhancing regulatory controls to restrict certain persistent contaminants. So I mentioned before, we're really worried about these contaminants that don't break down very easily in the environment. And so we've been able to establish a number of regulations. The prohibition of certain toxic substances regulations that's listed on the slide was put in place in 2012. But since then, we have had amendments to these regulations to strengthen the controls, and right now we're trying to add a couple new substances to this set of regulations to increase control of those substances as well. We are also looking to reduce contaminant releases by supporting upgrades to wastewater systems. So these upgrades are being done at the municipal and then the regional level in BC. As Christiane mentioned earlier, it's an ongoing effort, but we're supporting these, and a lot of this work stems from having to comply to the wastewater systems effluent regulations, which have been put in place for almost a decade now. So this work essentially takes these wastewater treatment plants from primary or untreated effluent towards secondary or tertiary level of treatment, which essentially means removing, being capable of removing more contaminants from the effluent before it's discharged into the environment. We are also working with enforcing regulations which is helping to detect offenders with high non-compliance for contaminants of concern related to endangered whales. And lastly, I thought I'd mention the announcement that came out a few months ago from Minister Wilkinson regarding banning the use of certain single-use plastics. So a list of single-use plastics is on this list, and this kind of moves towards the goal of having zero plastic waste by 2030. And so this initiative is related to whales in that, of course, plastics often make their way into the oceans just through litter, etc. So these litter itself is inherently dangerous not only to whales but to other aquatic organisms. But not only that, these plastics end up breaking down at some point once they're in the ocean. And once these plastics break down, we call them microplastics. they can end up within killer whales, within their prey, etc., and cause a whole bunch of health effects. So I just kind of wanted to wrap up with noting what can we do as the general public. And so I find with our work, and as Christiane mentioned before, especially with the Contaminants Technical Working Group, our work has been very collaborative in nature, and we've been able to establish really strong partnerships with the province, with non-governmental organizations, and our academics, our university researchers. But it's nice to feel that that there are individuals in public that can feel like they're doing their part as well. And so getting informed, being here is a great first step, and learning about the problem and learning about what kind of contaminants specifically we are concerned with. But some concrete things you can do include taking advantage of household hazardous waste programs. So making sure that if you have chemicals lying around in the house, in the garage, disposing of those properly. Same goes for electronic waste. And I put practicing green voting there because Georgia Straight Alliance has a great guide to green voting that's available on their website. So this is great for people who specifically on the water a lot for recreational use, getting their boats out there. It's got some really great tips to ensure that you're voting in an environmentally responsible manner. And then a really proactive way to get involved is to participate in shoreline cleanup events. I know that's not possible for most of us right now with the pandemic, but when it is safe to do so, getting out there and feeling like you're doing something really proactive can be very beneficial for some people. So I'll end off there. I just wanted to mention that we do have a website that is up and running. It was launched a few months ago at the end of 2020. So if you want to find out more about what we're doing, you can visit it. I can put the link in the chat once I'm finished with the presentation. And there, I also wanted to highlight that there's a link to a set of recommendations that were put forward by the Contaminants Technical Working Group last year. And so it kind of highlights some of the actions that we are taking stemming from the work of the Technical Working Group. So with that, I will leave it there, and I will pass things off to Kathleen.
Thank you, Shinjini. Happy to be here and see everyone. Let me just share my screen. I have 3 screens happening, so it's a little confusing. There we go. Share. Okay. Thank you, Shinjini, again. That was great. She gave kind of a broad overview and summary of all the great things that are happening. I'm going to delve into specifics about environmental quality guidelines. So like Christiane mentioned, I work for the National Guidelines and Standards Office within ECCC. So my group develops environmental quality guidelines for a variety of contaminants for a variety of media. So water, soil, sediment, etc., for the protection of the environment. So I'll be explaining what environmental quality guidelines are, and then speaking specifically about the work we're doing in relation to the southern resident orcas. So I'd like to start out with adding to what Shinjini already shared, which is the problem. The threat of contaminants is unique. It's sort of an invisible threat. So for example, the other threats orcas are facing, like vessel disturbance and prey availability, you can see these effects. You can see these threats. You can see the vessels. You can hear the noise. You can count their prey and know that the Chinook salmon populations are declining. But contaminants are more of a mystery, and it's quite a complex story. So we're dealing with a lot of different types of chemicals. So some that have been used for decades, like decades ago, and are now banned, that are bioaccumulative. So like Shinjini introduced, if you look at the food web here, so these contaminants like PCBs that are the example here, they bioaccumulate in the lower food chain and then biomagnify up to, say, the southern resident orca whales, where there's an elevated level in their blubber. And so PCBs is the example used in this figure. You may have heard of it. It's definitely the most researched and most attributed to the effects seen in southern residents. And they're an example of the forever chemical that is persistent and has been banned, but we're still seeing the effects today. And just an important thing to note here is that the orca whales are the primary source, primary exposure of these contaminants are actually coming from their prey. So it's not like their orcas are kind of swimming in the water or breathing in the air. They're actually getting most of their contaminant load from the food that they eat. So that's just an important thing to know. And actually orca whales have the highest levels of PCBs ever recorded in any animal. So quite intense. And one of the most concerning things, if you look at this food web, is actually the baby orca. Because we know that the whales are mammals, they do nurse their young. And so the mother can actually pass on a significant contaminant load to their young, a kind of toxic heirloom that becomes concentrated now in a very much vulnerable and smaller organism. So we have those kind of contaminants, and luckily over the years we've learned a lot. We've started developing better chemicals, so chemicals that are less persistent, less bioaccumulative. And so we saw this big shift from these biomagnifying chemicals that are a concern for these whales to more water-soluble, less persistent contaminants. And so these new chemicals are less of a concern for the whales, but they could also be affecting their prey, like the Chinook salmon. So this is so we have a mix of kind of historic chemicals that haven't gone away and a slew of new chemicals, all mixed in this chemical soup that the whales are being exposed to. That's the problem. And the goal is to obviously protect the environment, especially the most vulnerable, like the orcas, from the effects of these contaminants. And since this is such a big problem, a big solution is needed. So there's a lot going on, like Shinjini outlined in her presentation. And one of those things is by identifying safe levels in the environment of these contaminants. And that's where environmental quality guidelines comes in. So what are environmental quality guidelines? Well, in general, guidelines are science-based thresholds for environmental protection. And they're developed for a variety of environmental media. So we develop guidelines for water quality in soil, fish tissue, groundwater, sediment, etc. And so I wanted to give an example of guidelines using this figure. So say you go out to 4 different sites and you sample for a contaminant that you're interested in. And then you get your concentrations back from the lab of this contaminant, and you plot those on this just simple bar graph. Your next question would probably be, well, what does this mean? Should I be concerned? And that's where the guideline can help. That's the red line in this figure. It can give context to what we're seeing in the environment. And so now that we have this red line, we can say, okay, site 1 and site 4, those concentrations of the contaminant that we're interested in are below that guideline. And so that means that there's no to low likelihood that they're seeing negative effects to the environment at those sites. You also can say that site 2 and site 3 are above the guideline. And so that's where you get a red flag for further investigation at those sites, because there is a likelihood that there is negative effects happening. And so that's kind of how guidelines are typically used. They give context to what we're actually seeing in the environment. So some important things to note about guidelines. They are voluntary, so they don't have any legal standing themselves, unless they're prescribed in some sort of permit or regulatory tool, which they sometimes do. However, they're very well known, widely used, and therefore there is that desire, that expectation to meet them anyways. They are designed to be protective and preventative. So we want to make sure that, say, sites that are not contaminated do not become contaminated. We want to make sure all aspects of life in that environment are protected. So the guideline development process is designed in a way that makes sure these guidelines are protective and preventative. And lastly, they're publicly available. So whenever we do develop guidelines, they're posted online. They come with a write-up that describes how they were developed. So it's very transparent. They do undergo expert and public review. So there is always that opportunity for the public to provide comments. So it's quite a transparent and rigorous process. So what is the role of guidelines? So like I said, it's kind of a big problem. We're just kind of one piece of the puzzle here. And we like to say guidelines are one tool in the toolbox to be used with other kind of decision-making tools, risk management tools. They're used by a variety of different people, like risk assessors, risk managers, environmental impact assessments, monitoring and surveillance. And so, yeah, they're used within the government and outside the government quite a bit. And the example I gave in the last slide, comparing to monitoring data, is one of the main uses. And from that, we can establish priorities. So in those 2 sites that were above the guideline, those are now kind of red flagged priorities to look into to see if there actually is an issue and where maybe those contaminants are coming from. And if a real problem is identified, then we can risk manage those contaminants. And guidelines are often used as targets in risk management. So there is a role here for guidelines for the southern resident killer whale contaminant problem. So some things to consider when we're thinking about guidelines and southern residents, I wanted to summarize here in this slide. The first thing is that we're aiming to protect not just the whales, but their prey base as well. So we call them kind of 2 receptors. Because a chemical may not be directly affecting the whale, but it could be affecting, say, the Chinook salmon, or even something further down in the food chain, like invertebrates. And so we need to always remember that these are complex ecosystems. So one effect somewhere in that food chain can actually have an indirect effect to the whales themselves. And further to that, we're also looking at different types of contaminants. And like I mentioned before, some are bioaccumulative, those forever chemicals like PCBs that bioaccumulate up the food chain and are elevated in the orca's blubber. But we also have contaminants that are less bioaccumulative, that are more water soluble, but they are still a concern to the prey base. Guidelines exist for most, but not all contaminants. So we know we have some data gaps for sure. And my last bullet there is one of our main focuses right now, is that most guidelines developed up till now were not designed specifically to protect southern resident killer whales or other top predator marine mammals. And this is mostly due to the lack of data and limited toxicity tests that can be even done on these types of animals for logical and ethical reasons. So our existing guidelines are protective of the prey base, like Chinook, but we definitely do need to look further into protecting these vulnerable top predator marine mammals that have these unique aspects to them that I'll speak to in a couple of slides. So our first task was to compile existing guidelines that could be used in this situation. So we ended up recommending 59 guidelines, so some for water, sediment, diet, for 17 substances or substance groupings. So these are for the substances in that table that Shinjini showed in her slides. And so we summarize this all in just in a simple Excel spreadsheet that has some information like how the guideline was developed, where we got that guideline from, why we chose that guideline over potential others. And so this is kind of our work in progress, I think. It's kind of meant to be evergreen, so we do see potentially adding to it in the future. But it is available online, so I do encourage you guys to go check it out if you are at all interested. It is on that ECCC website that Shinjini ended her slides with. So you just have to go to the right-hand panel under Find Out More, and you can click on the guidelines link and it will download the Excel spreadsheet for you. So very exciting to have that publicly available. Okay, and so from that kind of exercise, we identified where we had data gaps. And the first major one that I mentioned earlier is that we're lacking guidelines that are protective of these top predators. And they have some unique aspects to them that are a bit different than, say, looking at a fish or an invertebrate. And so first, these types of animals are usually from vulnerable populations. And we certainly know that the southern resident killer whales are vulnerable with numbers in the low 70s. They also sit at the highest trophic level, so meaning that they don't have any natural predators. Their food chain is quite long, making them vulnerable to accumulate these bioaccumulative chemicals. And this is especially true because they have a long lifespan. So they can live 70, 80, 90 years, and all that time accumulating contaminants that they don't have any way of excreting or getting rid of. And lastly, they have a low reproductive output. Certainly makes it hard for them to bounce back from any of these kinds of threats. And something I guess I didn't really include here, but important to note that these are mammals. And so they do feed newborns with milk, which is a significant exposure pathway for the young calves. And then our second data gap is, well, we knew we didn't have guidelines for all the contaminants of concern. So we certainly would like to develop guidelines where we didn't have guidelines before. So I'm just going to talk about how we are going about filling those data gaps. And the first one, data gap 1, is being filled by first establishing a protocol. So before we go and develop guidelines that are protective of southern resident killer whales from these bioaccumulative substances, we first need to figure out how to do it. And we want to document it in a protocol, so kind of like a methodology protocol that is transparent and consistent and out there in the public and peer reviewed. So this is currently under development. It's a collaborative effort between my group, BC Ministry of Environment and Climate Change Strategy, and Fisheries and Oceans Canada, as well as a whole bunch of expert researchers that have been dealing with these contaminants in marine mammals for quite some time. So it's a great collaborative effort, and it's been really, really interesting working on it. And our hope for these guidelines developed following this protocol is that they're not just applicable to southern residents, but they're also applicable to other top predator marine mammals like them. So we're thinking like the St. Lawrence estuary belugas as well. And I won't go into details of the approach, mostly because we're not entirely finished yet. But essentially, we're taking a kind of a unique and novel approach to this, borrowing from human health risk assessment to make sure our guidelines are protective of individuals rather than populations or communities, which is often kind of the focus for environmental quality guidelines. But since our, an effect to one orca in the St. Lawrence, southern resident killer whales would have, it could have major consequences just affecting one individual. So we basically want to treat the orcas like humans and take that human health risk assessment approach. We're also taking a modeling approach. So the idea would be to say, find a concentration of a contaminant that causes no effect in the whale tissue. And then we want to model it down to, say, the tissue in their prey, and then water and sediment. And this is especially important because we can't, we don't want to go out and take blubber samples of orcas all the time. So it's a lot easier just to go out and take sediment samples to see what concentrations are in the environment. So it's very exciting work, and of course, it will be publicly available once we do complete it. Data gap 2 is being filled by developing guidelines where we didn't have them before, or they weren't sufficiently protective. So PCBs, like I mentioned before, one of the most highest concern will likely be the first guideline developed following this new protocol. So kind of be our pilot guideline. My group is also working on developing guidelines for a substance group called PFOA, which is another bioaccumulative forever chemical of high interest in general across Canada and the world. And we're also working on 2 pharmaceuticals and personal care products, PPCPs, are usually lumped together, triclocarban and metformin. Triclocarban, I believe, is an antibacterial, while metformin is an anti-diabetic found in diabetes medications. And these are examples of chemicals that are non-bioaccumulative. They're water soluble, so they're not really a major concern for the whales themselves, but they could be a concern for something like the Chinook that they eat. So those guidelines are currently under development. Once they are published, and they will go up to public review as well, they will be on our website, which is a link at the bottom on my slide. You could always just Google Federal Environmental Quality Guidelines, and all the guidelines that we've developed are found on that website. Okay, so this is my last slide. I just wanted to summarize what my group's contribution to this big project has been. So first, we recommended a variety of guidelines, which is the Excel spreadsheet that is now publicly available. And then from that, we were able to identify where we had data gaps, and we're now working on filling those data gaps, which includes guideline development, as well as co-developing this new protocol for the protection of top predator marine mammals, like the southern resident killer whales. And with that, I'll just say thank you. Feel free to contact my group at that email there. If you have any questions, I encourage you to check out the whales webpage. And thank you for being involved. And I'll pass that back to Christiane.
Great. Thank you so much for very clearly downloading a great deal of information. I've been working in this area of contaminants for a long time, and it's super complicated. So thank you for the clarity and for bringing it into the orcas world, which I think is certainly the keen interest of people. So I see we have a few questions. So I'm going to pass the mic to my colleague Lucero Gonzalez, who will share those questions for our panelists. And I'll let you, Kathleen and Shinjini, decide who gets to answer the question.
Okay, yes, we do have a couple ones. We don't know if we're going to get through all of them, but we'll try. Okay, there is the first question. Has there been any discussion of resurrecting bodies such as the Broad Inlet Environmental Action Program, which had many of the same goals and initiative as the current work, but was founded 20 years ago?
Oh, you want me to take it, Kathleen, or would you like to go ahead?
No, I think maybe you could take it if you're able to answer.
Okay. I'm not sure specifically about that specific program within the Burrard Inlet. I know that the Burrard Inlet Water Quality Roundtable is still active in coming up with objectives for water quality in the Burrard Inlet. So they're very interested, for example, in the work that's coming out of Kathleen's group. But I can't say specifically about certain programs. For the Whales Initiative in general, our funding is coming up for renewal soon. So we'll see where that takes us. But yeah, I can't speak to the funding of other programs.
I could just add that the Burrard Inlet water quality work, which is led by the Tsleil-Waututh First Nation, is quite amazing work. And if you're looking for the Burrard Inlet Action Plan, it's a great place to go for more information. I can say there was BEEP and FREMP were the two entities that existed at the same time, and I've heard some discussions at the Fraser River Estuary Management Plan. Their desire to bring that back, so that might be another way to have some conversation around contaminants and other issues for the lower Fraser or the entire Fraser. So back to you, Lucero.
All right, second question. Will there be an opportunity for eligible folks to work with Environment and Climate Change Canada on the Whale Initiative? And she says that she's in a few federal pools and wonder if anything will be coming up for the near future.
That's a great question, and definitely it's from our perspective, it's always exciting to hear that there's interest in working on it, as we really enjoy this work and find a lot of meaning out of it. In terms of whether there are positions opening up, I can't speak to it too well at the moment. As I mentioned, our program is up for funding renewal, so we're kind of working on that and seeing how that will all look in the next few years. So it's hard to say, but my advice would be to continue to monitor the jobs that are posted and see and apply for whatever seems that it would fit your knowledge base and qualifications, and see how that where that goes, where that takes you.
All right. Next one is from Anne Parkinson. They have 3 questions, so I'm gonna ask the first one, and we'll see how much time we have for the other ones. Uncontained EPS is banned in Washington and California. Any such considerations in Canada? The sand, pebble, and shell beaches in the Gulf Islands are sadly becoming embedded with EPS bits. The bits must also be filling the stomachs of killer whale prey. I think the question was any such considerations of banning EPS in Canada.
So EPS is a plastic, correct?
Yeah, styrofoam.
Yes, yeah, right. So I believe that would be linked into the whole banning of plastics potentially, but I can't speak to of banning myself. I don't know, Shinjini, as coming from the risk management, I don't know if you have anything to add, but I would assume that would be kind of lumped into the whole plastics file.
I would assume so as well. And neither of us work within the plastics division, so I don't know about that product specific, that particular plastic specifically. But I know that there is a lot of ongoing work on reducing plastics in general entering the marine environment. So I think that would fall under that program.
And I know as part of our green boating conversations, a lot of that the styrofoam is coming from docks and facilities. So certainly we're encouraging and working with marine facilities to get encapsulated systems in place, but maybe that is something we can look into a bit more and share that on our social media channels and find a bit more information. I'll probably be asking who to talk to to our panelists.
Right. And we'll go back to your other questions if we have time. Sorry about that, but we'll go to the next person, which asks, can you explain why water-soluble contaminants will be a concern for fish but not marine mammals?
Yeah, I can start, Shinjini. So the orcas, the marine mammals, they get most of their contaminant burden from the prey. So it's not that they, are getting it from the water surrounding or the air. They actually consume the prey, and that's where they're getting it from. Something like a fish, though, they have gills, and they can take in contaminants through their gills, even water soluble contaminants. So there's a little bit of different physiology, like you have some fish and you have the marine mammals. So there's just a different kind of exposure route for these two types of species. I don't know, Shinjini, you have anything to add there?
No, I don't.
Okay.
That would have.
Awesome. We have time for one more? Yeah, okay. How much of the chemicals we use at home in our day-to-day life affect Chinook or the orcas? And what can we do in terms of consumption and use to have less impact on the Salish Sea?
That's a great question. So we, from the federal government's perspective, we have regulations in place that prohibit the manufacturing and the selling of contaminants or chemicals that are deemed toxic. So over the years, a lot of contaminants, or I should say chemicals, a lot of chemicals that you would have had in your homes have now been banned. And a good example, I think, of that is flame retardants. So a particular class of flame retardants known as polybrominated diphenyl ether. It's a mouthful, but a particular class of flame retardants was prevalent in so many different household products, couches, mattresses, all sorts of different kind of furniture, curtains. But since we've learned more about them, we've been able to put those regulations in place to stop, again, the manufacturing and the selling and all that of that. Not to say you may still have some of these products in your home if they've been around for a really long time. But yeah, from our perspective, we try to regulate that way and ensure that the chemicals that are particularly harmful to these animals aren't entering your home in the first place. But in terms of what you can do with the chemicals that you do have in your home, as I mentioned, making sure that they're disposed of properly is definitely key. So once you're not using them anymore, making sure that they're not just dumped in the landfill or down the drain is really key. And staying aware of the types of products that you're using is really important as well.
Great. I see we are at near time, so unfortunately we won't be able to answer the rest of the questions. We will take a look at the questions and hopefully be able to share information if we can. And Sarah just put in the chat information about our Toxic Smart Guide, which is a program around reducing household chemicals and pesticide use, so as a means for you to protect your health and also protect the environment. So I want to thank everyone for joining us this evening. I really appreciate everyone's interest in this work. It's critically important to the health of southern resident killer whales that we continue to ensure that harmful chemicals are taken out of the water, and hopefully in bigger conversations about how to ensure these chemicals don't get in there in the first place. So thank you, Shinjini and Kathleen, for your time and all the knowledge you shared. I encourage people to go to the website for Environment Canada and certainly our website as well. And just a few, make sure I get my last notes in. I just want to make sure everyone notes that Orca Month is coming up in June, and Georgia Strait Alliance will be having some events during Orca Month. One in particular will be looking at the 2021. I lost a year like everybody else has, to look at the 2021 Southern Resident Killer Whale measures for protection and how boaters can actually, how it impacts boaters so that boaters can be aware when they're on the water. And we will be having other events as well. So watch our social media channels and find out what's going on. And also one fun thing we're going to do during Orca Month is something called plogging, which I didn't know about either. So basically it's a fundraising initiative, but it's also a way for you to connect with, get out in the air, walk, run, and also collect litter at the same time as a means to cleaning up our shorelines, but also raising some funds for our important work. So thank you again for joining us. Thank you to everybody, to our funders, our donors, to our supporters of all kind. Sharing this information with the community is also really important, and we look forward to having more conversations with you in the weeks and months to come. Thanks for joining us. Good night.